Welcome to the Good Viral Podcast.
We believe that people can and want to do more to help others.
So we invite you to join the conversation about the small and large ways that we can help people, animals, and the planet. We'll talk about real stories, like the turtle who had a straw stuck up its nose and how the video went viral in 2018 and changed the course of businesses like Megacorp Disney to change their straws to paper. We'll exchange exciting ideas and meet with guests who are actively making a positive impact with their time on this earth.
You don't have to do much to inspire a lot. Through this podcast, we want to make things easier for people like yourself to get involved.
When good goes viral, the world gets better.
Municipal solid waste is one of the largest environmental problems of today's world. But Benjamin Horvat, CEO of Lewis Structures, our next guest, is a startup green recycling process that is committed to working with the science and engineering community in order to replace landfills worldwide through low carbon footprint factories that will transform municipal solid waste into backfill for retaining walls and aggregate for construction projects. Lewis Structures focuses on everyday consumer trash that includes paper, cardboard, and stuff like plastic bags. In this episode, you're going to learn so much, and you engineers, you're going to just love this. Thank you so much for being with us here, Benjamin, with Demian and I. We're so excited to have you here on the Good Viral Podcast. You know, I've been following you on social media. We've chatted a few other times, so I'm really glad that you're able to come on board because we feel like you have such a cool idea and you have a cool business that's really helping the world here that we're going to get into in a second. So we're just going to start firing off questions, and I know Demian has his first question ready for you.
We were talking about this just a few minutes ago, and you had mentioned something about that for us was a little mysterious. You said in your that you thought that one of the biggest problems that existed in the world today was municipal solid waste, and skipping my original question to ask about that because I don't really understand that and what you mean by that. So can you share what you mean by maybe municipal solid waste is one of the biggest problems that we face today?
There's a lot of society that is really concerned about recycling, and they're saying, you know, we should change our habits. We should not have a plastic straw at a baseball game. We should try to go zero waste. And so there's communities all across the country that are saying, by this certain date, we're going to go zero waste. New York City, by 2030, I believe, is supposed to be a zero waste city. It's a really, really large community, and they're saying we must go zero waste because we have to treat our planet better. They didn't actually have a plan of how to get there. So I would say it is on the minds of most of Americans that the trash issue and the recycling issue is something that we care about. And yet, as I've heard people talk about it, and the desire so much to get it done that they're willing to restrict their liberties, restrict their normal patterns of life to get there, it's pretty astounding. And I've noticed with our technology, we can all of the single-use plastic beneficially with a one-time use of making garbage into a manufactured gravel. It's a lightweight gravel. It means literally that you could throw everything into the same trash bin, and we could take it all, and that actually would reduce smog because you'd have only one truck rather than two trucks going to your house. You wouldn't have a recycling truck and a garbage truck. You'd have one truck that takes it to one source, and it would save municipalities money, and it really would be better for the environment because none of it would go to a landfill. And in Chicago, I learned that there was a huge scandal just recently. They've been dumping for years all of the recyclables that people very carefully were setting aside just right into the landfill. And they didn't tell anybody about it, but they were saying, we're recycling, when in fact they were just dumping all of the recyclables that could have been beneficially used into the landfill. So I'm saying, I mean, that's dishonest, and I believe it was Waste Management that allowed that to happen as one of the largest companies in the world for waste. And so that maybe that was a localized instance, but the fact remains that this is the kind of scenario oftentimes that we're dealing with, that people say we want to recycle, but the recycling that we do is basically to put things into a bin, and that bin has to go somewhere. And they went to China for a long time, and then China said, we're not going to accept it anymore. So then we had all of these things that were supposedly recycling, but they didn't get recycled. All they did is they just got collected and then either stored in a warehouse, or the stuff that we carefully collected just was sent to a landfill. So we may have recycled as individuals, but society didn't really recycle at all. So I'm going like, well, what is that? So I do see it as a huge problem. But more so, I think it just needs some practical solutions that are large scale. I appreciate all the efforts of any company that I've heard to recycle. I think it's just good stewardship of the stuff that we have. There's a little bit of a difference between a group that says, okay, we're going to take this very specific kind of plastic and we're going to make flip-flops. Because I'd say, okay, that's great, but how many flip-flop manufacturers do we need in order to address 100 million tons of trash? And I'd say a lot, right? And even if it's, we can take the plastic and we can sell manufactured decorative plastic stones at Home Depot at $5 a bag or something like that. That's good, but it only addresses plastic and it doesn't address the rest. I'm a practical guy, and so as I was looking for a solution, it was like, I want to do something that will be practical to handle like the lion's share of this particular niche. And so I didn't want to do something that was fancy in a laboratory that didn't scale. And so we think we have a solution that can do large scale recycling at 400,000 tons a location. And then it really takes a pretty big bite out of the problem.
Yeah, and what I like about this talk here, if people aren't really catching on when they're listening, is the practicality, as you said, with this is that, there's lots of words spoken that we're going to zero plastic, we're going to be a huge operation of recycle. And I've also heard of these isolated areas that had recycle and waste just going into landfills and even barges and so on. And that has prevented and jaded a lot of people to not take action anymore, because they're like, well, if it's just going to go to the landfill anyway, why even recycle, right? And so I think what you're saying here is really helpful in that trash will always continue to be a thing. We are a culture that uses items and then we will discard items, whether it's from the grocery store or even if it's a natural resource like wood. And so things like that is still going to landfill in a large scale. And we do have these awesome companies that are doing their impact in some way or form and creating flip-flops and so on. But the trash world is so huge. I mean, I remember reading up a while ago just how many textiles end up into the landfills, and textiles being shirts, bed sheets, any kind of clothing really. And it was absolutely astronomical. I was like, how is this even okay? And so, hearing that you're able to take this huge problem and be able to, in a sense, take just about everything, it sounds like, and turn it into a product that then we can use for our infrastructure, kind of like in a future form, that this could really solve a lot of problems. So kind of tell us, we kind of hinted at a few things, but tell us a little bit about what happened for you that really sparked this mission or idea for Lewis Structures and recycling, this municipality waste and turning it into a practical construction use.
Probably a multifaceted story, but more recently in Racine, I was hearing, okay, it's the Kestrel Hawk landfill in Racine, Wisconsin, was near the end of its useful life. Essentially, in a couple of years, they would have to close it, and then we'd have to take all of the waste from Racine and truck it twice the distance away. And so that's twice the fuel. It's twice the wear and tear on the trucks, and the costs of transportation all across America are almost double right now. It's really hard to get semi-truck drivers, so there's a lot of cost in transportation. And so I was seeing that, and I'd be driving by on Highway 11, and I'd say, "Oh, okay, look at that mountain over there. That's all of our trash." I'd say that's a really, really big hill. Isn't there a good use for all that stuff that we're mounding up right over there? Sure doesn't seem like it. because we just keep on filling it up, year after year. And I'd say, what, isn't this the same all across the country? And it just doesn't make sense. And at the time, in 2017, I was checking into the market. Basically, there was a global university impact group. They were in charge of doing research projects. So I got them to do FOIA requests, the Freedom of Information requests, to a bunch of cities all across America, and I got the contracts for municipal solid waste and recycling, and their costs. And my dad is a numbers guy. He was an accountant and a small business owner for years, and he said, Benjamin, if you don't know your numbers, you don't have anything. Because you could be saying, oh, let's do this, and it's totally non-feasible because your numbers are way off. You have to know your numbers. Okay. So I got the numbers for cities all across America in terms of what they're paying for recyclables. And then I met this guy that had been in senior management with waste management for years. And so he flew all across the country, kind of overseeing various locations. And so I got to talk with various constituents of how much the transportation was. And they said, well, over 40 or 50% of the cost of the waste industry is transportation. So we are really, really shipping stuff long distances. And so there's all the smog attached to that. And then we're just dumping it. And I guess for years, New York would transport their stuff 12 hours away. They take the trash 12 hours away to then dump it in a landfill. So I'm saying, man, okay, so the local thing here doesn't look too pretty, and looks like it's bad in many places. But when I started working with, initially I started working with a retaining wall company on a property that I was thinking about purchasing. There was this vacant plot of land, and I could buy it for cheap. And I was thinking maybe I'd put like a starter home or like a mobile home on it or something, and that would be the start of my new residence. I'd be walking through this beautiful woods, and then a semi truck would drive by. Annoying because I'm a musician. I like my peace and quiet, and then I'd have this highway traffic that would like kind of ruin the moment of my time in nature. I wonder whether there'd be some way I could kind of block the highway with a hill or something. So I put an ad on dirtfill.com. This guy in a couple of days said, I have 8,000 truckloads of dirt for you if you'd like it. Where would we be putting it? I could build a berm for you, because I said that I was looking to build a berm. And that's, just a hill alongside the highway. And I said, whoa, 8,000 truckloads, that's a lot of dirt. But I did some research on how tall a berm or a sound barrier wall would need to be in order to block the decibel level and cut it in half. And this company, Tensar Corporation, they said, oh yeah, we totally could build you a wall, 20 feet tall, that would be pretty vertical. When you're walking in your woods and you're looking through a peace and quiet, it'd be a whole lot quieter than without that wall. So I said, that's cool, but can I just get like 200 trucks of dirt? He said, no, it's 8,000 truckloads or bust.
What?
Oh man. and he said he would build the wall for me according to specifications of Tensar, and they'd put like these layers of kind of netting that would keep it from erosion. And so that was the whole thing, to use like an engineering firm. And so I said, well, there's a lot of highway here. Maybe the other neighbors would like berm alongside their stretch of highway too. So maybe we could all partner with putting this berm up. That turned out eventually to a $30 million subdivision project where there was a berm entirely around 15 acres of property. And it never got off the ground. It never got it never got completed.
But on the ground?
But on the ground, lots of dirt, lots of ground. Launched from the ashes. Lewis Structures, my company. That's a short story. But what I realized eventually is that my guitar player at the church where I was working was one of the lead corporate attorneys for the business world in that particular area of the suburbs. And he said, you might actually have something that would work here. So I just did a lot of research, and my dad was always telling me, Benjamin, you're a little crazy. What the heck are you doing? what are your numbers on this and this? And he'd just continually be quizzing me whether I actually had something that was viable. And after 2 years of that, I knew my numbers pretty well. So we had a stormwater management and wetlands delineations, and but in the end, we met with the city, and they said, you could potentially do this if you have the engineering. And then an engineering firm was retained by a investor that said, I'm going to have these engineers check out whether you know what you're talking about. And so for 2 hours, they grilled me with all kinds of questions about subdivisions and the possibility of a gated community berm. After 2 hours, they said, if you like Benjamin, maybe you should give him the money, because this is very viable and this is pretty cool. We've never seen anything like this, but we like it. And he said, okay, we'll give you a check for $80,000 next week. You'll get it on Thursday. Well, Wednesday night, the guy called me. He said, I just lost a couple $100,000 and I'm mad as piss. I'm not investing in anybody. Goodbye. Don't talk to me. And it was like, I finally got to this point where I proved with an engineering firm that I was good. And they said, hey, so you studied civil engineering or land development, right, Benjamin? I said, no, I studied music. And they laughed. And I said, well, I just had a dad that was, really shrewd and was picking on me long enough until I actually got my stuff together. I learned a lot about that. When I came back to Racine, Wisconsin, I was remembering what my corporate lawyer said. He said, you have managed to do something that was not normal because you not only used dirt, you used construction debris for a berm. And normally you're not allowed to do that, but you figured out a way. But just don't ever do anything with trash, because they will crucify you. They'll say, you can't use trash in a commercial project. There's a really sharp dividing line. Once trash leaves your trash bin, it must go directly to the processing or the landfill, and you can't take any detours. If you do, you're violating state law. It's like, man, it seems like that's more restrictive. And what I learned was there's so much money involved that the people that want that trash want to protect their rights to it, and they don't want anybody to get a hold of it. So they make the laws such that you have to take it directly to there, so they get paid, basically.
Wow, I didn't know that. That's interesting.
And the landfill business has been unscrupulous. It's been I don't know the history. I don't want to color the landfill business like it's all bad. It's certainly not. There's a lot of great people in the business, but there's lots of restrictions, and some of the ways that the contracts were acquired over the years hasn't been altogether on the up and up. So I arrive back in Racine and I see this landfill and I say, I like the fact that I could build a berm with construction debris rubble, but there's an awful lot of just regular trash, and it's piling up, and it seems like, it's permanently in this landfill. And what if I could use this? Well, I met this scientist. He was a runner-up for a Harvard position. He was a molecular biologist and a environmental scientist. And he said, we totally could sterilize trash, and then maybe you could use it. That would be awesome. So I wasn't in school, but I got this teacher all to myself to a certain extent. And I was able to do some experiments with American Science and Technology, and they took some samples. Eventually, we were able to sterilize trash, so all the spores and bacteria were killed, and to normalize it enough that no matter what was in that trash after we shredded it down to a small size, then it was sterile. It was clean. We were able to harden it and make it insoluble. So whether water was with it or not, it didn't soften. It didn't turn into mush. And so I started doing experiments, and then eventually I met a European at a trade show, and I went over to Europe and tested with some equipment with a company there, and I brought it through customs, and and that was really tough to bring it through customs, because they said, you can't bring American trash into Europe, forget it. And so eventually we codified it as wood pulp insulation. And then they performed some of the tests that I wanted. And then we sent it back to Georgia. And the lead scientist, the material science for Tenzark in the Chicago area, he said, this works. We think you've created the 7th aggregate of the USA. You're the first company that I've ever heard of in my 20 years. This is the best thing that I've ever seen. That you've taken municipal solid waste or household trash, and you've made it into a gravel, and that's never been done before. I was trying to keep things under wrap, but I called up the investor that said he'd give me 80,000 and pulled out. And I said, "Hey, we got something that we think you might be interested in," and he said, "Okay, I'll give you the money to get the patent stuff done," and so we got patent protection.
So I have, I have a couple of questions. You've raised some really interesting things. So our audience is global. I don't know if you know that I'm in Barcelona right now. So
no way! Oh my gosh, I should have asked. Oh,
so and Anastasia is in Colorado. So
yes, I knew that. I was thinking you.
Yeah, we're talking from all different places, and of course our listeners are all over the place, all over the world. So so really, this is a very, very interesting global issue that you're talking about, and there's a couple of things that I wanted to ask you about, because we're going to make sure that our listeners know who you are, and we're going to point them to your website and any of your social media, make sure that they can find you easily and understand who you are. A few things, even after I've done research on you and your company, I still don't understand so well, and that's why I want to ask you specifically. So my first question is, so what you said before is that through the technology that you're utilizing, you can convert municipal waste into something usable, and it can be all types of waste. Basically, doesn't really matter what it is. So what can you do with it? Because my thought when you said that was, okay, well, municipal waste is a large volume and it's never going to stop. So, at some point we're going to make everything that we can possibly make with this material, and then what, right? So what can you do with it?
Well, from our standpoint, we are making an aggregate, and so one of the beauties that I've learned about the whole thing about a factory is you bring in machines in a building, and those machines are tweaked with all the gears and the parts to make something to specification. So if you have the hole at the end of the machine bigger, you get a bigger product coming through the hole. If it's a smaller hole, you get smaller things. And I mean, obviously that's a super simple analogy, but we can make aggregate at virtually any size. We can add stuff to it to make it heavier. We can make it lighter. We can the densification of the material, and also the strength of the material, like how much psi pressure can bear down on the aggregate before it breaks. So we found in the lab that my aggregate could withstand 600 pounds of pressure or 5,000 pounds of pressure, depending on how much additive we use.
So to kind of rephrase a little bit of what Demian was getting at, and I think that what you just said there was really key, Benjamin, because when you create this aggregate, what can be used for aggregate? Like, is it building buildings? Is it also creating burns? Like, what are some of the products that can be created from this aggregate?
Yeah, so the major uses of aggregate in the world today are for road-based material. So I'm not talking about the asphalt itself, but below asphalt is typically several inches of gravel that has to be put down before they put the asphalt. And so our labs have shown that our aggregate, and it's called MSW Ag, Municipal Solid Waste, MSW, and then AGG aggregate, MSW Ag, or MSWAG. We got some swag.
Yeah. There you go.
So MSW Ag can come in many different forms, and we have various sizes in strength levels, the shear strength of the material. Road based is a huge one. So I mean, picture how many roads are there in the USA? All of them require gravel. That's a $17 billion purchase of the American public every year. Every single year in perpetuity, they're spending $17 billion for gravel.
Wow.
I shouldn't say it's just roads, but if we only did that and nothing else, we could have a bunch of factories and never run out of replacing virgin aggregate with our aggregate. And Dr. Ewan with SGI testing labs, the primary testing labs for Tensar, is saying you've met all specifications, all requirements are entirely met by this from a mechanical standpoint. But then there's concrete. So whenever you make concrete, what is it made out of? What goes in concrete?
No, here we
Gravel. I think it's gravel, is it not?
Gravel is one of yes,
most of that.
Well, 50% of it is gravel, and so our gravel is 60% lighter than normal, say, crushed limestone. So crushed limestone might be 2,500 pounds. Ours is like 1,200 pounds. So when 50% of concrete is now 50% lighter, that reduces the weight of the concrete, and that has really exciting benefits. So University of Michigan and University of Wisconsin-Madison have both said, hey, we're really interested in potentially using your gravel with various forms of concrete. What if all that could use a renewable aggregate? So whenever you mine aggregate, then it takes a whole lot of diesel fuel to take excavators and crush this rock. And then you get this big chasm and you put a bridge over it, and then you kind of look at it, wow, that's a lot of stuff we took out of there. But if we didn't need to spend all the diesel fuel to do that, and instead we had a consumer byproduct aggregate that did the same job, that would be huge for the impact on the ozone layer. The carbon footprint of creating virgin aggregate is substantial, not just for mining it, but then transporting it. So if you're creating trash somewhere, and then you're able to process it very close by, so there's almost no transportation distance, and then you're able to take that and utilize the gravel for a construction project really close by, you've cut the transportation out of two industries. You're not transporting 12 hours like New York City did to a landfill. You're not wasting the stuff in the landfill, and then you're not expending a huge amount of energy to take it out of the dirt, and then it's gone forever. And then the third is simply for retaining walls, and so that was the original thing.
Excuse me, Benjamin. A retaining wall. Can you tell me exactly what that is? I don't understand exactly what is a retaining wall. What does that mean?
Oh, okay. So a wall that is made of dirt is typically what I said before. It's a mechanically stabilized earthen wall. So it involves using backfill, and backfill is fill or dirt. Backfill is dirt on the backside of the wall, and it's retained by having layers inside that wall that keep it from eroding. When you retain dirt, you are stabilizing it. So a retaining wall is basically a mechanically stabilized earthen wall. It's a wall that has layers in it, basically, that are engineered that way so it doesn't erode.
Okay.
And a retaining wall doesn't always have to be something that's a perimeter. It can also create structures and can create fences, very large, big fences, and it can create any kind of construction piece. Dams especially. What I find is really, what I find is really interesting. I know you're kind of mid-story there, but I kind of want to reiterate this for the audience here, is that when we're talking about gravel, I'm from the country as well here in Colorado, and I personally actually know people who own gravel companies here in Colorado, and the mining that they have to do is just absolutely huge. And unfortunately, environmentally, not only are we just taking dirt out of the ground, but we're also creating a residual issue from that mine and the water we use for hundreds of years even. And I have engineers in my family that are environmental engineers, and they specifically work with miners so that they can reduce that as much as they possibly can, but it's practically impossible. So what I love about this, Benjamin, is that Loose Structures not only comes in and takes care of a trash issue, but it creates, an aggregate, a tool that we can use. So we no longer have to do so much, at least mining. I mean, mining will continue on until we no longer need electronics, but so mining will continue, but it will continue less. And so this also means that the environment not only benefits from having less trash in it, it also benefits from not having to use so much mining for the gravel on the immense amount of building and reconstruction we have to do, not only in the United States, but potentially the world as well. And so I find this absolutely awesome in that it kind of creates a cool ecosystem within itself to really help not only environment, but to help communities too, because who wants to put a house on top of a landfill? That's where we're getting at, is we're now building communities on top of old landfills, and landfill ground is not the greatest. It's pretty toxic. So this is a lot of issues that this company is really addressing, and I think it's absolutely fantastic.
I've got a big question for you here. This is because what you've been sharing with us is really amazing. It's what we're talking about is essentially solving the trash problem in making it totally reusable. And it's obviously a global issue. And of course, what we're here doing, what Good Viral is all about, is trying to look at, or you might say, highlight companies like yours that are actually doing something to solve the most important problems that we have, so that we can make this world a better place while we're here on this planet. And that's what we're all about, and that's why we're talking to you. But my big question, my burning question is, okay, so this is a beautiful, amazing idea. How do we take that that thing that you're doing and make that on a global scale to where it's the thing that is done? In other words, where we basically really solve this problem of municipal waste.
Oh, I'd love to see it happen. I really would. We'll be signing a contract for our first pilot facility in the Midwest, maybe in the next couple of weeks. We are hoping that we will get a decision from the National Science Foundation to launch the technology through that program. They have a phase 1 funding of $256,000, and then $2.2 million somewhere around there for phase 2 funding. So we heard about it. A bunch of our scientists participated. I don't know if I had half a dozen or more that were put into the proposal, and it turned out to be 215 pages or so. And they asked us a bunch of questions initially. Is this solving a global problem? Is this scientifically based? Is the engineering feasible and sound? And so we submitted 10 pages first, and they said, we really like this, and please submit a full length proposal of how you use 256,000. And so we did. And then they said, okay, wait 6 months. And so you're just kind of like, oh, I hope 6 months from now we'll get this money so we can do something. And $300,000 of private funding to verify a lot of stuff. But there's just, if you look at one scientist experiment in a laboratory and you say, okay, we verified this one thing in a test tube, the difference between that and providing a global solution for everything under the sun getting stuck in a landfill, and now saying that we can do it all. Oops, I just bumped the computer. It's a really big difference. So a lot of National Science Foundation things, I think, are super narrow focused, where you're saying we're gonna put a spike chemical into this test tube, and that might provide a drug that will provide a solution for this ailment or this disease or something. And that's really, you can spend a lot of time getting that little thing perfectly, but with trash, you can't sweat the small stuff. You have to do something super fast, like 10 tons an hour, in order to even scratch a little bit of existence out of the big problem. So, so what I've realized is, in order for my solution to work, I don't need one experiment. I don't need one invention. I need 20 inventions that all have to synergetically work together in order for it to be profitable, for people to change their ways from using landfills that they've used for decades and decades to an entirely new thing. It involves so many different industries. And then once you do it, then you have to prove to the construction industry that's very conservative that they should no longer use what they trust, which is rocks, and use a totally different kind of rock. And so the biggest thing for us, and I'm this is kind of a roundabout way to answer, but I think it's necessary to say from a practicality standpoint, we have to prove that we've actually cleaned the trash. So when people get this aggregate and they put it on the side of the road, they don't think it's going to be contaminated. And so the whole point of our technology is essentially to dishwash the trash. So you say, oh, there's nasty stuff on that plate. let's wash it and then we can put it back in the cupboard and we feel good about eating on it again. Well, if you were to just take trash and you were to, make it into hardened pellets, but you think that ultimately there's some nasty stuff in there, nobody would want to use that, right? You wouldn't trust it. You wouldn't let your kids play around with their tricycles on your gravel if you thought there was some contamination in that gravel. You wouldn't do that.
Of course.
Foundation of our technology is to prove beyond any doubt that not only it works mechanically, but it also works environmentally from a contamination standpoint. We got a couple of sleeping bags recently from a house that we helped people move out of, and they were pretty smelly. And so we put them in the washer. After washing them, they still smelled bad. So I put it in again, and I used more soap the second time. And after that, I felt like I really did a good job of cleaning the sleeping bag. And so when we have visitors, maybe we'll, and we're camping, we'll give them one of the sleeping bags that we got. But in the same way, what I realized was if our technology, which is specifically designed with American science and technology and other leading scientists, isn't effective at entirely removing all contamination from trash, then we can put it through the washer a second time. And the second time worked, even if the first one didn't. And then I was saying, well, okay, but it costs twice the money to wash something twice, right? Well, is there enough money involved to merit washing the thing twice if I needed to? If in the end I said, sometimes they put really nasty stuff in trash and our process doesn't get it all out the first time. And I realized that there's enough money involved. I could wash it 3 times or 3 times the amount of time in the washer to make sure that it got cleaned, and we'd still be profitable. But before we go global, we have to have one location, right? And read what's there.
Excuse me, Benjamin, in terms of cost, I think that a bigger question really is the cost of not doing what we're talking about is the big cost. And that's the cost that has to be factored in, is that this we must solve some of these issues. And we cannot, as a human race, continue to create trash at this level and the pollution that it's creating to create, again, the gravel and everything that we have to do, as you say, to transport the trash and everything. I mean, really, those costs need to be factored in at a global scale by governments, by everyone, not just, of course, obviously the costs for the profitability of your company, but if your company is able to be profitable without even factoring in all of the what is the word for that? The negative hidden costs, or whatever you want to call that. Environmental costs. Yeah, sure.
Yeah.
Exactly. If you can be profitable, then without a doubt, we know that this is something that needs to go forward.
So, Benjamin, what's the best way that you're feeling that anyone who's listening, who, whether they have connections or they just want to make sure that they follow you and help support you in some way, what do you feel is the best way that our listeners can help support you?
The awareness that you're bringing through your podcast, I think, is absolutely incredible. So I'd say spreading the word that there are ways that landfills can be used less, I think, is probably one of the most important things. When that word gets out there, I think eventually landfills become a dinosaur, and dinosaurs eventually die, and we get on to doing something better. And so we're saying we have that, and we've demonstrated, kind of like my original subdivision project, that the engineering is sound, the science is sound, and the economics are sound. It is possible to do this profitably, so investors can get involved. We're accepting equity positions in our company, and I think the return on investment would be well over 20% on the conservative side, but it could be astronomically more than that if we're able to get our first, and then eventually scale to numerous locales across the USA, because we can essentially replace a landfill with a factory.
Right.
And once we get our first one going, and maybe we'll have one in the next 8 months if this $4 million investor comes through, or this larger one that we're currently talking to. We just need a pilot scale, but we're profitable even at a pilot scale. And if we show that to investors, then they can start franchising this to places all across the country and potentially other places in the world. And we'd like to be conservative enough that everybody who invests makes a good return on their money. So it's not just like angel investment or give us a handout because we're doing something good for the planet. We are doing something good, but my dad is a guy that says you got to pay attention to the numbers too, and numbers drive the landfill industry and the recycling industry. And we are able to do the good and also get a really good return for the investors or whoever wants to help us. We got the contracts ready to sign, and we'd be glad to take on additional partners because we need to help so we don't die on the vine.
Spread the word and share this episode to everyone you know, not only to hear Lewis Structures' story, but also what problems are out there and the solutions that you provide, and really pick up this momentum so you can get the support, monetization, or municipality or science-based kind of support that you're needing. So thank you so much for being on the podcast, Benjamin. This has been absolutely amazing. I'm sure Demian and I just learned a lot and are now going to really, as I've said this before on another episode, and I've told Demian this many times, as we continue to have these conversations with people like yourself and others, I go to the grocery store in any store and I'm incredibly careful with what I'm purchasing now, because I know that it ends up either in that supposed recycle bin or into that trash bin, and that impacts something somewhere.
Thank you for listening to the Good Viral podcast and being part of the conversation. If you are inspired by this episode, go to our website at goodviral.org, where you can find resources and listings from the episode to continue good efforts.
Like, comment, and share this episode to any or all of your social media channels. It's really easy to take a small action, and maybe you'll inspire a big result.
When good goes viral, the world gets better.